Hai, Assalamualaikum. For part 1, we use smooth surface. For part 2, we must use rubber surface. Repeat these steps 3 times. So from me, thank you.
Assalamualaikum, my name is Ali Azina binti Izam and my student ID is 20259849 and I am from class AS1201B. And today I will be explaining about objective, apparatus and procedure. The first one would be objective. The objective of this experiment is to measure the static friction coefficient across various surfaces and to examine static and sliding friction forces and the factors that affect it. And the last one is to gain a solid understanding of static and kinetic friction.
Hi, my name is Aiman Shahidah binti Abdul Hamid, student ID 2024530237. In this part of the video, I would like to talk about the introduction of this experiment. The purpose of this experiment is to examine static and sliding friction forces, which is Fs and Fk, and the factors that affect it. The factors that are examined within this experiment are the surface area of the object, the type of surfaces in contact with one another, and the force of gravity or weight. All of this will be tested and compared to see how they affect the value of the friction forces. Friction is a force that always opposes the motion of an object. According to velocity, friction may be classified into static friction force, Fs, when velocity is equal to 0, and static friction force, Fk, when velocity is not equal to 0. Next, static friction force is a force between two objects that are not moving relative to one another, and Fk is a force that will act on the object. Static friction force occur when two objects are moving relative to one another, with one object sliding across the surface of the other, and it opposes the motion of the object. Both types of friction are described by different coefficients. These values are known as the coefficient of static and sliding friction, μs and μk, respectively, and they are dimensionless. The coefficient of static friction, μs, is usually higher than the coefficient of sliding friction, μk. Coefficient of friction, μ, is a measure of how easily one object moves in a relationship to another. When you have a high coefficient of friction, μ, you have a lot of friction between the materials. Regarding to this explanation, we carried out one experiment where a small block was placed on the experiment surface as shown in figure 1. When no force is applied to the block remains at a stationary position. At this position, the normal force and F of block is equal to its own weight. When a pulling force Fp is applied to the block parallel to the horizontal surface, a friction force Ff is acting in an opposite direction to the pulling force Fp. If Fp is smaller than Ff, the block is not moving. If Fp is equal to Ff, the block is about to move. If Fp is greater than Ff, the block is moving in the direction of Fp with acceleration. The resultant force is given by the formula resultant force equals to Fp minus Ff. After that, we can calculate the coefficient of static and sliding friction, μs and μk, using the formula μ equals to Ff over Nf equals to Fp over W.
Next one is apparatus. The apparatus that we'll be using in this experiment is wooden block that are covered with rubber at one side, and then 50 gram of measures, 10 Newton spring scale, string, and tabletop. Image 1.1 is showing wooden block, and image 1.2 is showing spring scale. For procedure, the first step would be the mass of the wooden block was measured and recorded as m, and second step is the apparatus was set up as shown in figure 5.2. Number 3, the stability and horizontal orientation of the tabletop was ensured, and next, the spring scale and the wooden block was attached with string and was placed horizontally on the tabletop. The rubber side of the block was ensured to be face downward. And then, 50 gram of mass was placed on the wooden block, and the spring was pushed slowly, and once the block started to move, the spring scale's reading was recorded. The value as F was recorded and tabulated in table 5.1. After that, step 4 until 5 was repeated for 3 tires. Another 50 gram mass was added to the wooden block, and step 5 to 6 were repeated. The steps were repeated until a total mass of M, 500 gram, was on the wooden block. Lastly, step 1 until 8 was repeated and ensured that the rubber side of the block faced upward and tabulated the data in table 5.2.
For discussion, number 1, how can anti-lock brakes stop a car in shorter distance than a regular brakes? The answer: kinetic friction is used to slow the vehicle down with it comes to a stop if the wheels lock up. However, because static friction is greater, anti-lock brakes pump the brakes so that the tires experience static friction rather than kinetic friction, which causes the vehicle to slow down faster and over a shorter distance. For question number 2, from your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? The answer is the wooden block with rubber has the highest coefficient of static friction. Hypothesis is correct. The coefficient of static friction, I believe, is determined by the ratio of the maximum static friction force between the surface in contact before movement begins to the normal force. For question number 3, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. The answer is because the block of wood and rubber has higher frictional force that exists when the object accelerates or experiences a change in velocity. A body at equilibrium has a net force which is equal to the sum forces acting on the body.
Hi, my name is Nur Shakira Shahmina binti Nur Amali. My student ID is 2024539225. I would like to talk about discussion. The experiment was done to determine the coefficient of static friction of different surface. The coefficient of static friction could be determined from the plotted data of the graph. First, we need to know the highest and the lowest coefficient. In order to determine the highest and the lowest, we need to calculate it by using this formula. Mu F divided with N, where F is the frictional force and N is the normal force. Because both F and N are measured in unit of force, such as Newton or pounds, the coefficient of friction is dimensionless. The coefficient of friction has different value for static friction and kinetic friction. To find N, mass need to be multiplied with 9.81 mm per second square. After the coefficient has been calculated, we can see that the highest coefficient is rubber, meanwhile the lowest coefficient is non-rubber. The gradient obtained from the graph were used to calculate the coefficient of static friction, mu s, for each surface using the formula of gradient, m equal to y2 minus y1 divided with x2 minus x1. From the graph of the rubber surface, the coefficient of static friction is 0.414, while for the graph of the non-rubber surface, the coefficient of static friction is 0.393. The difference between the coefficient of static friction of two surfaces is equal to 0.021. Why the coefficient of the rubber is higher than the non-rubber coefficient is because higher coefficient require larger force to pull the block. The reason for this is the very low elastic modulus of rubber and the high internal friction exhibited by rubber over wide frequency region. The friction force between rubber and rough hard surface has two contributions commonly described as the adhesion and hysteretic component respectively. To prove this, the object with mg provides us vertical downward, which is called as normal force Fn, causing a friction force between the object and the plane. A body at rest remain at rest, or if in motion, it will remain in motion at a constant velocity unless acted on by a net force. An object will sliding across the table slow down and goes back due to the net force of the friction acting on the object. Free body diagram are diagrams used to show the relative magnitude and direction of all force acting upon an object in a given situation. A free body diagram is a special example of the vector diagram that were discussed in an earlier unit. There are four kinds of force that exerted the block, which are Fs, Fn, Mg, and F. As an example, based on the diagram below. There were a few things that could have been done better during the experiment. When dragging the spring scale, the observer eye should be positioned perpendicular to it. This is to prevent reading error that contain the data. Afterward, obtain a series of readings from various observed throughout the observation to reduce parallax error resulting from inaccurate scale reading.
Hello and Assalamualaikum. My name is Nurul Nadira binti Muhammad and my student ID is 2024959795. And my part is to present about the results. First is the mass of the wooden block with rubber surface, which the weight is 82.0 gram. As for the uncertainties, the mass of wooden block is 0.01, and the result that is shown in this slide is the result that we got during this experiment. As for the first column is about the mass, 3 gram masses, which is the black one. As for the total mass, is combination of the mass of the wooden block and the block 50-gram masses. As for the total weight, we use the formula F equal to mg. F is equal to W2, which is weight, equal to total mass. And you have to convert it to kilogram, and then you will multiply with the gravitational forces, which is 9.81. As for the static friction force, we would have 3 trials, and you have to sum it up, all 3 of them, and divide it by 3 to get the average result. For the second one, which is the non-surface toward the floor, and all the column and the information is just the same as the rubber surface. However, the value of non-rubber surface is much lower than the rubber surface. Next is about the analysis. The first analysis is to draw and label the free body diagram of the wooden block. And we will show the picture of how we draw the free body diagram and what type of forces that exerted onto the block. They have 4 forces, which is the friction force, the normal force, the weight, and the force. And for the second analysis is about to plot the graph of static friction force Fs against the normal force for the rubber surface and the non-rubber surface. And in this slide, I will show you 2 graphs that I plotted for the rubber surface and the non-rubber surface. The third analysis is to use the gradient obtained from the graph to calculate the coefficient of static friction for each surfaces. In this slide, I've provided you the calculation and how I get the coefficient from the gradient, which is m equal to y2 minus y1 and divided by x2 minus x1. And as we all know, that coefficient is equal to the gradient. For the last analysis is to compare and discuss the coefficient of static forces that we obtain. Coefficient for rubber is higher than non-rubber. This is because the rubber needs a lot of energy or forces, which acquired a big amount of coefficient to pull the block. As we know that force is directly proportional to coefficient. Thus, the larger the forces, the larger the coefficient.
My name is Nur Aznaikil Azhar. My student ID is 2024991257. We talk about conclusion. In this experiment, precise measurement of the static friction coefficient are conducted using a control setup. Various surfaces with different level of roughness are tested against a standard material or surface. The goal is to quantify how the coefficient of the static friction changes as surface roughness varies. This involves using instruments like force sensors or friction tester to accurately measure the force required to initiate sliding motion. The difference between coefficient of static friction occurs because of surface roughness. Simply told, the objectives in this experiment has been achieved. To find the uncertainties of coefficient, we will use this formula. Delta M equal to delta X per delta Y. The value of square Y was obtained by finding the square root of the sum of the Y, while the value of square X was obtained by finding the square of the sum of the X. Thus, the uncertainties coefficient for rubber surface is 0.414 plus minus 0.647, and for the non-rubber surface is 0.363 plus minus 0.627.